Assalamu alaikum students. I hope you all are doing well. First of all, I would like to warmly welcome all of you to class 8. This is a new class, a new session, and a new journey of learning and growth for all of you. I hope you are excited to explore new concepts and challenges in mathematics. Um, So, as you all know that my name is Mr. Dasif, your mathematics teacher from SM Public Academy Campus 5. I'm really happy to start this journey with you. I'll try my best to make my classes easy, interactive, and interesting for everyone. Student, I just want one thing from you that please participate actively in the class. Don't hesitate to ask any question because making mistake is a part of learning, as we all know that. So we have already discussed chapter sets in class 7, standard 7. Remember that what is set? It is a collection of objects gathered together and treated as a single whole. These objects in a set are called elements, as we all know that. In this way, we represent a set with a capital letter. This is called the notation. And here 1, 2, 3, 4 are the elements of the set. One thing which we always have to remember that whenever we are representing the set, repetition of elements are not allowed. That means distinct objects must be there because it's a collection of distinct objects and also well-defined object. What is the meaning of well-defined? A set is well-defined, meaning that for any given object, we can clearly decide whether it belongs to the set or not. For example, if we have set of months of the year, it's well defined because we can always say that the month of April, the month of June. But if we have, if we say that there are the set of beautiful flowers, it's not well defined because different people have different opinion about the beauty. So it's not a well defined set. So well defined set. A set is a well-defined collection of distinct objects. As we can see, there is an example, color of traffic light. If we say that set containing color of traffic light, it will be red, yellow, and green, right? So in this way, we can represent our set. So, class, this is our book which we are going to follow for the session. This is New Countdown Enhanced Blended Edition. So, we begin with the chapter number 1, that is set. Student, this is an important chapter. In previous classes, we have already learned about that what the sets are, and now we will learn how to combine and compare sets using different operations. Just like we perform addition, subtraction with the numbers, we also perform operations on set, such as union, intersection, and difference. So, what will be the learning outcomes, your learning objectives for today's lecture? You'll describe sets using language of sets, descriptive, tabular, and set builder notation, and Venn diagrams. You'll find power set of a set A where A has up to 4 elements. So, how can a set be represented, or set notations? How many set notations are there? Set can be written in 3 ways. Number 1, tabular form. It is a form like in which the elements are separated by the commas and enclosed within the braces, or we can say that curly brackets. So this set represents A is equals to 0 till 4, right? If I want to describe this sets, but in the mean of statement, in the um in the form of statement, then that way of representation of set is called descriptive notation, right? So if I want to describe the set, I will say that set of whole. Why whole? Because 0 is included over here. So set of whole number less than 5. Why less than 5? Because 5 is not included here, right? So in this way, we can describe the set. If I uh, if I remove the 0 from this tabular notation, then I will write set of natural numbers less than 5. Now, if I want to write the set in the form just like that set is expressed as a root, in the form of root, then it is called the set builder form, where set is represented in the form just like that set is expressed as a root, right? So if I want to write 0 till 4 in set builder notation, I will write like that x such that this vertical line, I read like that such that. So meaning such that x means elements. It represents x represents elements here. So elements x such that x, that means elements is a whole number. That elements belongs to the whole number, and whole number kaise whole numbers? Less than 5. Yes. The whole numbers are there, and they are, what are the limitations? This less than 5 shows you the limitation in the set. So the set is ended at 4 because it's less than 5. So these are the 3 forms. These are the 3 notation in which we can represent a set. Now, let's discuss subset and superset with Venn diagram. What is subset? A set is a subset of another set if every element in a set is also the element of the other set. For example, here A contains 1 and 2, and B contains 1, 2, 3, 4. This set contains 1, 2, and set B contains 1, 2, 3, 4. As we can see that 1, 2 is already presented in set B, That means we can say that A is a part of set B. Set A is a part of set B. That means elements of set A are already there in set B. So set A is a subset of set B. I will write set A is a subset of set B. This sign, this shows you the symbol of subset. It is a symbol of subset, right? So A is a subset of set B. And what about B? If A is a subset, then what is B? And B here is a superset of A. And what is the symbol used for the superset? The symbol is like this, right? B is a superset of set A. And how can we draw the Venn diagram for this question? We have to draw the big circle for set B because it's a superset. And if A set is a part of set B, we have to draw that circle within set B, inside the circle B. We have to draw the set of A inside set of B to show that BA is a part of set B. What are called proper subset? A proper subset contains some but not all the elements of another set, right? For example, if A contains 1, 2 and B set contains 1, 2, 3. In this question, in this example, we can see that A contains 1, 2 and B set contains 1, 2, 3. That means A is a part of set B. That means it's a subset. But we can say that it's a proper subset because A is not equal to B. Why? Because B contains element 3, that is an extra element. So we can say that A is a part of B, but A is a subset of B, but it's not equal to B. Then A is a proper subset of B, right? What is the condition for proper subset? That one set must be the part of another, but all the elements are not present in another set. That means all elements must not be equal in a sense. So this is called the proper subset. Clear, students? Now, what is improper subset? If a set is a subset of itself, then it is called improper subset. For example, A set contains 1, 2, 3. Then A itself is an improper subset of A. Or we can say that if there is one more set B, and it contains the elements 3, 2, 1. As we can see, both the sets containing same elements, and when the elements are equal, these kind of subsets are called equal and improper subset. So I can say here, for this example, B is a superset of A, or B is a improper or equal subset of A, or A is the improper subset of set B, right? Now, let's talk about the power sets. The topic which we have to discuss today is power set. Power set is a set of all the possible subsets of that set. ठीक है? A set having all the possible subset of that set. Its symbol is P, capital P of A. Matlab, what is the meaning of that? Power set of the given set A, right? Power set of set A. So, quickly, let's start with an example. Let's take example for the power set, how to find out the power set of the given set. Students, if set A is given with an element only 1, right? If we have only one element that is 1, how can we find the power set for such kind of question? To find the number of elements in the power set. There is a formula to find the number of subsets in the power set. So the formula is number of elements in the power set. PA is equals to 2 power n. Now what is n? N represents the number of elements. Now here the number of elements. How many number of elements are there? Only 1. Count the number of elements. Only 1. I'm not talking about the elements. Okay, what is the value of element? I'm just talking about how many elements are there. So there is only one element. So I will write 1. So here it becomes 2 power 1. And 2 power 1 means 2, right? That means how many subsets will be there? 2. How many power sets will be there? 2 in this question. So if we talk about the subset, the first subset will be null set. Why null set? Because null set is a subset of every set. Clear? And the second subset will be 1. Right? The set itself. Right? The set itself. So how many subsets are there? 1, 2. And how many number of subsets we require? 2. That's it. We get the answer. Now, what about the power sets? It's so simple. If we have already find the subsets over there, we just have to put the curly bracket around it to get the power set. Look, there is only one difference between subset and power set. We have to put the curly brackets around the subset. If we put curly bracket around our subset, then it becomes a power set, right? So to make a subset, we have to convert subset into, how can we convert subset into power set? By putting just curly bracket around it. So this is an example for the power set if we have only one element. Now student, if we have two elements, then the formula will becomes, how many elements are there? 1, 2. Number of elements are here 2. So the formula is PA, power set of A, 2 power n. So let's write 2 power n. N means number of elements, and how many number of elements are there? 2. So we get 2 power 2 means 2 is multiplying twice. So 2 into 2 is 4. So 2 into 2 is 4. That means in this question, I require 4 subsets and 4 power sets, right? So we have already discussed in our last example that uh, null set is a subset of every set and a set itself, right? Set itself and null set is a subset of every set. So in this way we get 2 subsets. And how can we find 2 more subset? Just write first element separately and the second element separately within the curly bracket. Don't forget to mention the all the subsets within the curly brackets, because if you don't mention it in a proper way, if you write like this 0 null set 1. Acha, remember one thing that I can show null set like this empty curly bracket and also like this, right? I can write the null set like this also. So we are not allowed to write the subset directly like this. We have to put the curly bracket around it. So in this way we get null set 1, 2, and then 1, 2. And simply if we want power set for this subset, I have to put the curly bracket. I have to put the curly bracket around it. Now, students, if we have more than 2 elements are there. For example, if I have 1, 2, and 3. If in our set I have 3 elements, then the formula will become 2 power 3. So how many number of elements in a power set will be? 2 threes are 6? No, absolutely not. 2 power 3 means 2 is multiplying thrice. 2 power 3 means 2 is multiplying thrice. So we get 2 twos are 4, 4 twos are 8. Okay, that means this time I require 8 number of subset. How many number of subset? 8 number of subset. So every time just remember that first subset always will be null set, right? So after that we get 1, 2, then 3. One more element is there. So the next element will be 3, right? The next element will be 3, then 1, 2, right? First is null set, then write all these 3 elements separately, 1, then 2, then 3, then combine 2 elements together, right? 1, 2, first write down 1, 2, then write down 2, 3, right? Then write down 2, comma, 3, then 1, 3, next will be 1, comma, 3, right? 1, 3. And then what we have to write? 3, 2? No, we cannot write 3, 2 here. Why? Because already we have written 2, 3 as a subset, right? So which subset is left? How many subsets are there? First, let's count it together. 1, 2, 3, 4, 5, 6, 7. That means we require only one more subset. Just think about it. Which subset is left? Yes, very good. The last subset will be the set itself. That means the last subset will be 1, 2, and 3. So this is all about the subset. And in the same way, if we want to convert it in the power set, we just have to put the curly bracket, additional curly bracket around it. That's it. So simple. So in this way, we can easily find the power set with 3 elements, right? So so this is about if 3 elements are there, right? If we have 3 elements within the set. What if we have 4 elements in a set? For example, if we have 1, 2, 3, 4. So how can we find the number of elements in a power set? So the formula here is again 2 power n. So how many elements are there? 1, 2, 3, 4. So here we get 2 power 4, and 2 power 4 means 2 into 2 into 2 into 2. That means 2 is multiplying 4 times, we get 16, right? 2 twos are 4, 4 twos are 8, 8 twos are 16. So how many subset I require here? I want 16. How many number of subset I require? I want 16, right? So first of all, we know that uh, null set is a subset of every set, right? Now, we can write separately single elements like this one, then 2, then 3, and then 4. After writing separately, we can make the pair of the elements like 1, 2, 1, 2. Then let's make a pair of 1, 3. Let's make a pair of 1, 4. Let's make a pair of 2, 3. Then 2, 4, 2, 3, and 2, 4. And then finally 3, 4 is there, right? So null set, then single sets are there. Look, null set, then single sets are there, single elements are there. Then pair, having a pair of 2 elements together, we get like this. Now, after completing all the 2 pairs of elements, we can write 3 elements together. First of all, 1, 2, 3, like this. Then 1, 2 combined with 4, 1, 2, 4, right? Then I can write 1, 3, 4. Then I can write 2, 3, 4, like this. Clear? Just like that, if I'm having elements 1, 2, 3, 4. How many pairs? How many 3 elements can join together? First of all, 1, 2, 3, then 1, 3, 4, right? Then 1, 2, 4, then 2, 3, 4. So in this way, I where I make I combine three elements together, right? And finally I can write a set itself like this. Clear? So let's count it together that how many number of subsets we got here. We've got 1, 2, 3, 4. That's in. Let's stick together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. That means we have got all the subsets for this set A. So similarly, just what we have to do, we have to put the curly bracket around the subset. We just have to make curly bracket around it to get to convert the subset into power set. Just curly bracket. So so in this way we can find the subsets and power set for the elements for the set having 4 elements. Okay. So before winding up, let's discuss what is your assignment, what you have to do at home. So students, this is assignment 1. You have to start this assignment in your maths classwork copy, or you can say that arithmetic copy. For maintaining of your index, first of all, write down midterm with the black marker, then write down with a neat and clean handwriting, write down chapter number 1, operations on set. Then on the next line, write down definition and exercise 1, question 3, bit 3 and 4. It is based on power sets, right? And then I have written all the instructions for you. You have to mention the date on which you are completing this assignment. Leave 1 page for midterm syllabus. Then you have to make the title page of chapter operations on set. Then write down subtitle as well. Then start with the definitions of 3 sets notation in arithmetic copy from your book page number 3 and 4. Okay, from book page 3 and 4, write down the 3 sets of notation definition from that page. And then what? And then complete this question 3, bit 3 and 4. It is based on power set. Okay. Just find out power set for bit number 3 and 4. And finally find the revise the tables, and that's it. That's all for today. And students, if you have any query, any problem about today's lecture, you can ask me. You can discuss me through GCR or in your physical classes. Thanks so much. Take care of yourself, everybody. Allah Hafiz.